Hi, James Earl with CSBreakdown here today, and we're going to be going over an introduction to cryptography. So we're going to go over a few beginner cryptography algorithms, and then we're going to talk about how they work and how you can crack them, and specifically why they're no good anymore. So let's dive in. So generally in cryptography, we're considering two people communicating back and forth, and we're going to refer to them as Alice and Bob. So this is just a convention that's generally used. And the idea is that Alice is trying to send Bob some message, and Bob is of course going to try to respond to that message. But they're trying to send each other this message without the third listener, Charlie, knowing what they're talking about. So Alice and Bob are both able to agree on a key prior to their communication, so that Alice can send Bob a meaningless message, and using that key, Bob can translate it to understand the real meaning. But the listener, Charlie, without knowing the key, is not going to be able to translate the message and understand what they're talking about. So let's go over an example of a fairly simple cipher that uses this sort of methodology, but we're going to talk about why it's actually a bad cipher and how easy it is to crack. So the Caesar cipher is sort of the pinpoint cipher that people use when they're getting into cryptography, and the reason for that is because it's quite simple, and you can actually do this one by hand and crack it in just a few minutes by hand. You don't need a computer for this, and it's referred to as the Caesar cipher because it was used by Julius Caesar. And the key that's used is going to be a number indicating a shift of letters through the alphabet. So what I mean by that is if you had a key of 5, every letter is shifted 5 letters forward, and of course that wraps around. So if you had the word hello world and your key was 5, it's going to translate into this text here on the right, which is completely meaningless, of course. But if you knew the key, you could just apply it backwards and you would be able to get the original meaning. So the reason this is such a weak cipher is because there's only 26 possible shifts. If you had a shift of 1, every A would translate to B, every B would translate to C, and so on. But if you had a key of 2, then it would be A to C, B to D, etc. But the big problem with this is it's such a finite search space for trying to find out what the actual shift is. You could just do this by hand. So to translate this ciphertext, you could use frequency analysis and actually consider the number of occurrences for every letter in the ciphertext and apply that to the standard letter frequency in the given language. Of course, this is letter frequency in English that I'm showing on the screen right now. But for this cipher, it's actually going to be faster to just try all 26 combinations until you get something that's meaningful. And of course, you could imagine that we probably wouldn't even have to exhaust all 26 combinations, because if their key was 13 or 15, we don't even have to go all the way through the list. So this is actually a very, very weak cipher. It's just to get you into the mindset of actually translating text and sending it for a person to translate backwards using that key, which in this case is just a single number. But we're going to talk about a slightly more advanced but still very weak cipher called the Substitution Cipher. Now, this cipher is actually very similar to the Caesar cipher, but the alphabet is not shifted, it's actually just a random key. So your key is going to be 26 characters, so 1 character for every letter in the alphabet. Of course, I'm using the English alphabet. And you apply every letter as a mapping. So in this case, I've given Z, P, Q, R, etc. And these would map A to Z, B to P, C to Q, and so on. So by doing this, we can map from our regular alphabet and actually disguise our text in a more random, nonsensical way. But you're going to see why this is still actually a very vulnerable system. So let's say this is our key, and our plain text was CSBreakdown on YouTube. This is going to translate to the ciphertext UXK, etc. And you'll see that the big problem with this is that the letters translate to the same letter every time. So if there's ever the letter O or C or B or anything, it's going to map to the same letter every single occurrence. So let's take a look at this. We've got the words CS Breakdown on YouTube. So the letter O kind of appears a few times, especially given that we have the spacing in our ciphertext. So let's take a look at SJ, and then YouTube translates to S, F, S, Y, N, etc. We can see that S appears both times as the O, and because we know O is going to appear the exact same number of times it appears in the ciphertext, just mapped differently, we know that we can use the letter frequencies, just like I discussed prior, to sort of figure out what this might actually be. So when we're trying to figure out the ciphertext and how it maps back, we're trying to discover the mapping, we can just consider that the plain text letters map to the same ciphertext letters every time, so we just use letter frequencies. So in English, I believe the most common character is E, followed by the letter T, and so on. So if you had a very large ciphertext, let's say it was hundreds of characters, the letter that appears the most often in that ciphertext is likely going to map to E, and the second most commonly occurring letter is likely going to map to T. So as a result of this, you can actually use these letter frequencies to get an idea of what the plain text is actually going to be. Now, this again was a very introductory view of cryptography, and it's not always going to be this easy. There are many more difficult ciphers, such as the RSA, the Vigenere cipher, the elliptical curve cryptography, and lots of public key systems. And a lot of these use computational difficulty as their big strong point. And we're going to talk more about those soon, so I'm going to be releasing videos on a few of these topics. But for now, I hope this video has helped highlight an introductory view to cryptography to really get you to understand the idea of encrypting your messages using some key in a cipher that can be decrypted easily, but without the key, it should be difficult to decrypt. And the examples I've given are actually quite easy to decrypt without the key, but we're going to be going over some more difficult ones in future videos. So for now, thank you all for watching, and please be sure to like and favorite all of our videos. Thank you.